Okay, in this DevCast, I'm going to go over array destructuring, destructuring arrays. Okay, so what is destructuring arrays? It reminds me a lot of pattern matching in other languages. So let's get an array of some numbers. Okay, and this is one way to extract the values. Right. So here's the first value of the array. It's stored in variable num1, num2, num3, num4. Okay. So if I were to console log num1, num2, num3, num4, you can guess that the result will be 11, 22, 33, and 44. Okay. Let's do some array destructuring. Now that's when I'm able to do basically multiple assignments instead of doing this long format here. What if I was able to do num1, num2, num3, num4, and assign those values each to numbers. All right, so this is a new feature that will be in a future version of ECMAScript. So my node monitor should blow up, and so it does. So it's saying that it's invalid syntax. Basically, unexpected token. It's not going to allow me to do this in the latest stable version that I'm running, which is node 5.6 or 9 or something. So instead of running our app or our script with typical nodemon, I'm actually going to use the Harmony flag called Harmony Destructuring. Okay, so that's -- Harmony _ destructuring. That'll allow us to perform the destructuring syntax. So there you go. 11, 22, 33, and 44 are assigned through this syntax here. All right, so let's go over a couple of other things about destructuring. First, you don't need to have every number matched. So I can, even though there's 4 numbers up here in numbers, I can assign just 3 of them if I want. There you go, 11, 22, and 33. I can also skip a number. So if I were to put an empty expression here, then what will happen is we skip over the 3rd element, and then num3 gets assigned to the 4th element, like that. So it's 11, 22, and 44, right? So same thing here. You can remove that element and this entire element and just console log 1 and 3, which should give us 11 and 44. All right. So another thing we can do is something called the spread operator. So if I said use the spread operator on num3, then that takes the rest of the arguments that are left and applies it to num3 as an array. So as you can see, we have num1, which is 11, num2 is 22, and num3 is an array of the rest of the elements in the numbers array. Okay, so this is actually really cool. It allows us to write in ways that other functional programming languages typically write. So let me demonstrate. This. So let's create a function, function expression, and we could also destructure the arguments, and let's call it head, and we'll spread the tail. Okay. We'll use a fat arrow for the function. Now let's see, if we console log the adder, and we pass in numbers. Okay, So let's look at what head gives us. Oh, you know what? Let's just invoke it first. And let's console log the head and the tail. And as you might guess, the head should be the first element, right? Just like we were showing how destruction works up here. The first element is here, then every other element will be stored as a variable called tail as an array, right? So this line we expect to be 11, and this should be an array of the rest, right? 22, etc. Okay. Oh wait. I'm just gonna not console log that. All right. So 11 is logged first, and then the rest, 22, 33, and 44. So this allows us to actually write some functions, much like other functional programming languages like F# and OCaml, and let's say we want to add all these numbers up. We can do it recursively. So let's write a base case here. If tail length is greater than 0, then we'll return. We'll add the head, which is the first number, to, and we'll invoke ourself again, the tail. Okay, and if that is false, then we'll just return the result, head. Okay. All right, so let's read this line here. We're allowing an array passed in as an argument, and if the tail has a length greater than 0, so there's still numbers to be added, then we'll add it to the head, which is the first number, and we'll return that. We'll also pass in the tail to be destructured again every iteration of the recursion. Okay, so let's now console log the adder numbers. So hopefully we should get 110. Good. All right, so that's nice. I mean, we could use reduce to do this as well. So let's just take it a step further and rewrite the adder function using features of fat arrows that allow us to return a single expression, so a one-liner. So if we remove the block, then it will return an expression returned here. So let's do a ternary operator. And again, we can omit return because it's implied. So using implicit return, I can return this such as this. So now we have our adder function here, and it's still adding to 110. Okay, now if you wanted to, you could rewrite it a little bit to remove some extra symbols and make it a little bit more readable if this is more readable to you. So this is still a ternary operator. Okay, so our adder function takes in an array and then checks if there's any more numbers to add to our head, then recursively adds to the result, and then returns the result using implicit returns of the fat arrow function. All right, so that's it. Thanks.